one. So what we're going to be talking about is factor labeling. This is just an introduction to factor labeling, or what is called dimensional analysis. And basically the idea is converting. That's all it is. That's all we're going to be talking about is converting. And the notes part of it really is probably about, I don't know, this part of this is actually notes. And if you take a look at the rest of it, it's really just problems and it's tips. And if you flip to the back of this page, it's just a bunch of problems. That's all it is. Some of which may not look like they're science at all. Okay, science-based problems. So like, here's a question about a pizza party that someone's throwing in. Maybe like you had a question in your pre-quiz that was about someone who was going to a leadership conference that needed to bring enough chocolate for the s'mores. So there are things like that where it's not necessarily science, but we want to make sure that you understand the process of problem solving and story problems, which most people do not like and are not very good at, okay? Which is why it looked like the 0 out of 3 was definitely the average in this class as far as the points go. So what we're going to do is we're going to talk about this problem solving. And if you were one of those people that know how to problem solve, this is different, and that's why we're able to apply this and spend the time in chemistry to be able to learn how to do this problem solving, even though it's not technically chemistry. We do it and we use it to our advantage, and it's in the chemistry books. And so I guess that's it. That's why we're doing it here. So it's called dimensional analysis. Everybody say dimensional analysis. Dimensional analysis. Or factor labeling. It means the same thing. What we're basically going to do is we're going to use conversions, which we call equalities. Equalities because you are setting two things what to each other? Equal to each other. For example, an equality would be 60 seconds per minute. You can say 1 minute equals 60 seconds. You can say 60 seconds per 1 minute, or you can just say 60 seconds per minute, okay? How many inches are in a foot? 12. It's an equality, and it's 12 inches equal 1 foot. Or 1 foot equals 12 inches, okay? But you can't have it backwards. You can't say 12 feet equal 1 inch. So just to keep in mind the equality, you need to make sure that the numbers go with the proper unit. And we had talked about the biggie small rule before. We said that typically you can put the big number, or the big exponent, with the smaller unit. What number went with the bigger unit? The number 1 was the one that we assigned with the bigger unit. So if you were switching kilometers to centimeters or centimeters to kilometers, it doesn't really matter. We put the exponent, which kilometer to centimeter, you've got 2 to centimeters and 3 to kilometers. That was a total of 10 to the 5th. Then basically all you would need to do is say 1 times 10 to the 5th goes with a centimeter, and since kilometers are bigger, you put the 1 with a kilometer. So it's things like that that we've already talked about. We're going to kind of bring it together now. There's a scientific mathematical way to get the correct answer to more difficult problems each time. And it's a systematic way, and it works every single time. And I was one of those people that didn't like story problems because I got lost once I was past the first sentence and got into the third and fourth sentence. And I was like, what? What do I do now? Where was I going? So we're going to solve these problems. And the first thing I want you to do is I want you to pull out your calculators. And I want you to calculate without writing anything down. How many seconds are in 1 year? That's all I want you to do is calculate how many seconds are in 1 year. When you get the answer, I want you to raise your hand. And once 5 people have the answer, I'll have those 5 people call out what their answer is in a certain way. So once you get the answer, just go ahead and raise your hand. I've got 1, I've got 2, I've got 3, 4, 5, 6, 7. Okay, here we go, 8. On the count of 3, those of you that got it, I want the first 2 numbers of that long number in your calculator. I want the first 2 numbers. 1, 2, 3.
31.
Perfect, 31.
Yes.
31. Your answer should be 3153600, yes?
Yep.
Seconds. Okay. Now, some of you got it really fast, and there are other people that are like, what? I'm not sure what to do. What do I do first? Where do I go? I felt like maybe we'll go with you. You came up with your answer. You were one of the first people to raise your hand. Mm-hmm. So what did you do in your calculator? What did you type into your calculator, and kind of why?
I did 60 times 60 because 60 seconds in a minute, and then 60 times that answer times 24 because that's how many seconds in an hour.
Or minutes.
Yeah.
You did 60 minutes in an hour. Good.
Yeah, and then I did 24 times the answer I got after multiplying it by 24 times 365.
And why'd you use 24? Because there are 24
Right, yeah.
hours in a day. Good. And then the last thing you did was?
Multiply it by 365 because that's how many days are in the year.
Awesome. Okay, and that happened very quickly, and for some people it was less than 10 seconds, and they got their answer. But I want to make sure that everyone gets the answer right, and we're only using this as an example because it will only get more difficult. Right now, this is something that you've been using ever since you were, whenever you could understand time. You've been using time, and so you know the idea of seconds, and you know the idea of minutes and hours and days and things like that. So what we're going to do now is you're going to be given things like moles and molecules and formula units and atoms and ions, things that maybe are not something that we really understand that comes naturally to us. And so to be able to do calculations with things like that, we're going to use this to help us, this method to help us. Okay? So here's how we're going to do it. Everybody's going to repeat after me. The circle what you want, write what you got, throw in a bridge, cross units opposite. Ready? It's right here if you don't remember it. Here we go. Circle what you want, write what you got, throw in a bridge, and cross your units opposite. As long as you use this method, you'll be guaranteed to get the correct answer every single time. And again, I want to remind you that the only reason why we're doing this is because it's going to help us with chemistry. Otherwise, throw it out and let the math teacher teach it. We're not going to waste time in this class. Okay? So let's come back up, and here's how we're going to do it. We're actually going to go backwards. First thing we want is what are we ending with? What's our target? What are they asking us for? What are we looking for in this problem? Seconds. Has to be a unit, okay? Write what you've got. They're only giving us one other piece of information, and what is it? 1 year. Then you're going to throw in your bridge, and you're going to cross your unit opposite. Now you can abbreviate it. You can make it YR, and it can be plural or it can be singular. It doesn't really matter. So 1 year, 1 years, so many years, it doesn't really matter, okay? So plural or not. And what do you know about years that are going to get us closer to seconds? We know what?
There are
365 days in a year. Now, if you don't know, I'm sure you do in this case, but there's this little conversion sheet that I had created. The way that I broke this up was I have mass, length, volume, temperature, and time. And time's down here at the bottom, okay? And so what you're basically going to do is you're going to try to find what conversions or what equalities are going to help you get from one place to another. But you need to make sure that there's no gap going from one place to the other, okay? So if you're, now the other piece of it, because you're seeing that there's mass, length, volume, temperature, time, the other piece of it is I also broke it up so that it's in English versus SI, which is the international system that's used. And then there's English to SI. The problem in the US is that we use English. But in science, we use SI. We use this system, which is grams and kilograms and milligrams and micrograms. We use the meter and we use liter for volume, okay? But in the English system, we use things like instead of grams, we use things like pounds and tons. And instead of saying liters, we use cups and we use ounces. And instead of using meters, we use inches. So because of that, we need to convert. And this over here, the English to SI, is going to be the equality that we're going to end up using quite a bit to be able to do these conversions and to be able to switch. Right now, we're just in the time area right here, which is pretty easy. The one thing that might help us to speed up this problem is they tell us that an hour is 3,600 seconds. But besides that, you pretty much know your time units. So we said that in 1 year, there are 365 days. Would it be okay to put 365 on the bottom? No. It would if you were starting with days and you were trying to cancel days out, but because we already have years on the bottom there and we crossed opposite so that they could cancel out, which is what happens right there, then you have to make sure your equality makes sense. Okay, so 1 year is 365 days. I don't want days. So where do I write days if I don't want days? On the bottom, because that will cancel it out. There will be problems where you have a unit in your denominator that you don't want. If that's the case, you're going to write it opposite on top instead of writing it on the bottom. So you can cancel out in both directions too. So now I'm in days. And how are days going to get us closer to seconds?
24 days.
Perfect. 24 hours in 1 day. So hour or hours in 1 day, and now my days cancel out. Perfect. Now I'm in hours. So I'm going to cross that opposite. And what do you know about hours?
60 minutes in an hour.
Yep, there are either 60 minutes in an hour, or you can jump straight to 3,600 seconds in an hour. Let's do that since we have the conversion. 3,600 seconds in 1 hour. And now my hours cancel out, and I'm left with seconds, which is what I wanted. what do you do in your calculator now? Well, remember, same thing as what we did before. This is the top of the bridge is representing your numerator. You want to multiply first. Order of operations is multiply, then divide. If you want to, in this case here, they're all ones anyway, so you're only dividing by 1, so you could just ignore it. You can just do 1 times 365 times 24 times 3600, and what do you get in your calculator?
3100.
Yeah, this number right here. Awesome. Okay, Sig Figs. For this, because we're typically we would be using Sig Figs and we would use our least number when you're multiplying and dividing of Sig Figs. But since this is something that is just a count, it's not a measured something, we didn't actually measure anything, we're not using Sig Figs for this, so whatever answer you get is what you're going to say your answer is, and we're done with that. Okay? So that's basically the introduction. Let's do one more. Let's do this Jenny and Joe problem here with the building a fence. So trying to build a fence, and it's 135 meters long. And they want to know how much it's going to cost just for the nails. Okay? So imagine that you wanted to build a fence and you wanted to see how much it would cost for nails. You find out some information. Underline the information you're given. 135 meters long. We're also given this information that there are 50 nails per meter of fencing, which we're going to write as 50 nails per meter. And there's one more piece of information. And it's that there are 45 nails for $3.45, which I'm going to write as 45 nails. Make sure you always include a unit per $3.45. One of the hardest parts is circle what you want. What do you want in this problem? Cost, but cost is not a unit. What is the unit of cost? Dollars. That's what we're looking for. It has to be a unit, otherwise you're going to have trouble answering your question, okay? So that's the first thing. Second hardest part of this is write what you've got. There are 3 options. We can start here, here, or here. And I'm going to tell you, you're going to write this down. If I'm ending with 1 unit, because it's really hard to figure out, I start with 1 unit. Okay, and what I mean by this is, if you're ending with something like seconds, which would be considered 1 unit, okay, instead of seconds, something per seconds, okay, that would be 2 units. Then, when I want to end with just 1 unit, and that 1 unit can be something like hours, or minutes, or maybe it's years, okay? If you're ending with something like miles per hour, for example, that's 2 units. Miles is considered 1 and hours is considered another. That's 2 units. I want to start with 2 units. So that means that I actually want to start with something over something, x over y. And this would be representing 2 units. So maybe it's centimeters per second. Maybe it's milliliters, I'm going to do meters per year. Okay? So it's something like that, ... Okay? So you can have different units where if you're ending with 2 units, you want to start with 2 units. If you're ending with 1 unit, you want to start with 1 unit. Because I'm going to tell you that looking at this problem, we have 3 different places that we can start. Circle what you want, write what you've got. Here's the problem. Then, person says, yeah, but Mrs. Ismail, okay, so I figured out what I want, what I'm looking for, but now I've got 3 places that I can start. I don't know which one to start with, and there is a correct one to start with, okay? If you start with the wrong one, it could take you a really long time to answer the question. So, write what you've got. You want the one that only has 1 unit. Which one is it? The meters. 135.0 meters. You're going to throw in a bridge, and you're going to cross your units opposite. Is there something in the problem? So I'm checking this off because I already used that, because that's the only one that has 1 unit, that has meters in it, that we haven't used yet. Perfect. The 50 nails for every 1 meter, per 1 meter. So now my meters are gone, and I'm in nails. Now I don't want nails. So I write nails opposite. And what do you know about nails that we have not used? 45 nails, so I need to write the 45 with the nails. Remember, you can't do 60 minutes in a second. Costs how much? $3.45. Last step is plug it into your calculator, because we got dollars and that's what we wanted, and everything else canceled out. Go ahead and type it into your calculator, and what do you get? What did you get? 155?
0.25.
0.25.